We are said to prove that root 3 is irrational. We can use a proof by contradiction by stating root 3 is rational. A rational function is just like p on q, that is a fraction. Okay, let's say that root 3 is equal to p and q. And from our initial condition, p and q, p all over q can be further simplified. That is, it will remain like this. Okay, further simplifying this, we are going to have what? 3q squared is equal to p squared. Proceeding with this, we can from here conclude that 3 is a factor of p squared. Therefore, 3 is a factor of p from here. Okay. So, p is equal to 3m, m being an integer. Since 3p is equal to 3m, since it's a factor, at any point we can have it. Okay, proceeding with this, we are going to be having what? Substituting this back in the initial equation, we are going to have 9m squared is equal to 3q squared, which implies q squared is equal to 3m squared by division. Okay, proceeding. Hence, 3 is a factor of q squared from here. Therefore, 3 is a factor of q2. Hence, from here, this initially contradicts our initial proposition that p can be on q can be further simplified. Hence, contradicting our initial proposition that root 3 is rational. Hence, root 3 is irrational using proof by contradiction. Thanks for watching this video. Goodbye.